Hi, welcome to Land of Chemistry. Simple steps to organic chemistry. In this video, we are going to learn the acylation reaction of amines. Come on, let's get into the video. Acylation of amine. The acylation is carried out by reacting either acyl halide or acetic anhydride in presence of a strong base like pyridine with amines to give the amides. Come on, let's learn the reaction. CH3, CH2, NH2. For our convenience, I am writing this NH2 in this way, NH and H. This is ethyl amine. We are going to react it with acetyl chloride, that is CH3, C double bond O, Cl. The reaction takes place in the presence of pyridine, which is a strong base. What happens during the reaction? The hydrogen from the amino group and the chlorine from the acetyl chloride will leave as HCl. The remaining, this carbon will get attached to this nitrogen. So we get CH3, CH2, NH, C double bond O, CH3. The name of this compound is N-ethyl ethanamide. Come on, let's react the same ethylamine with acetic anhydride. CH3, CH2, NH, H, O, C double bond O, CH3, here C double bond O, CH3. This is acetic anhydride. The reaction takes place in presence of pyridine. Here the hydrogen from the amino group of ethylamine and here CH3COO. Together it will leave as CH3 C double bond O OH. So COOH, which is known as acetic acid. The remaining thing, this carbon will get attached to this nitrogen. So we get CH3 CH2 NH C double bond O CH3, which is known as N-ethyl ethanamide. So far, we have learned the reaction of primary amine with acetyl chloride and acetic anhydride. Now, we are going to learn the reaction of secondary amine with the same reactants. Come on, let's learn that reaction too. Now, we are reacting diethyl amine, that is CH3, CH2, NH, here CH2, CH3. This is secondary amine, which is known as N-ethyl ethanamine. We are going to react it with acetyl chloride, that is Cl, C double bond O, CH3. The reaction takes place in presence of pyridine, which is a strong base. What happens? The hydrogen from the amino group and the chlorine from the acetyl chloride will leave as HCl. The remaining, this carbon will get attached to this secondary amine group. So we get CH3, CH2, N, C double bond O, CH3, here CH2, CH3. The name of this compound is N, diethyl ethanamide. Come on, let's react the same diethylamine, that is the secondary amine, with acetic anhydride. CH2, CH3 plus O, C double bond O, C double bond O, CH3, CH3. What happens? As we learned earlier, the reaction takes place in presence of pyridine, the hydrogen from the secondary amine group and the OCOCH3 from the acetic anhydride will leave as acetic acid, that is CH3COOH. The remaining, this carbon will get attached to the secondary amine group. So we get CH3, CH2, N, C double bond O, CH3, here CH2, CH3. The name of this compound is N, diethyl ethanamide. Here, the reactivity series of amine with the acyl group is primary amines are more reactive than the secondary amines. and the secondary amines are more reactive than the tertiary amines. This is due to the steric hindrance. Okay, this is due to the steric hindrance. Okay, as in the secondary amine, the steric hindrance increases when compared to the primary amine. In tertiary amine, the steric hindrance increases when compared to the both primary and secondary amine. So the reactivity order of the amines with the acyl group is primary amine is more reactive than the secondary amine, and secondary amines are more reactive than the tertiary amine. This is due to the steric hindrance. Okay, as the steric hindrance increases with the higher substitution, it makes more difficult for the acyl group to attack the amino group. Thank you.